That makes a lot of sense. All right. What we're looking at today is the last part of the notes yesterday, which actually ends up being 2 slides. So we'll probably get these done pretty quickly. Evaluate each trigonometric function. Cosine of 4 pi over 3. Well, there's different ways we can go about it, and they want us using reference angles here. Well, 4 pi over 3 is bigger than pi over 2, so we would want to find the reference angle. Now 4 pi over 3 is between pi and 3 pi over 2. So what we would do is on the side we can take 3 pi over 4 and subtract pi from it. Now if we're using the graphing calculator, we don't want to do this in terms of pi, because we could say 3 pi over, no, it was 4 pi over 3 minus pi. Gives us this. And when there's no way to turn it back into terms of pi, it doesn't work that well. So if we want to do the graphing calculator, what we do is remove pi from it, because pi is in both terms, so we know pi is going to be left in the end as part of the answer. 1 over 3, or pi over 3. Now the 30xs, we can do 4 pi over 3 minus pi, and it will do it in terms of pi. Now we get cosine of pi over 3. Now I can come back to the previous slide. I see pi over 3. Cosine is 1/2. So I can come over here and say that this is 1/2. Now we need to be careful because, again, we're in the third quadrant and cosine is negative in the third quadrant. Mode, turn it into radians, second quit. Because I could say cosine of 4 pi over 3 and it'll do it also. Tangent of negative 210 degrees. Now we can get it back between 0 and 360 if we want. And to do that, we're going to take 360 and add it to negative 210. Which will give us the coterminal angle of 150 degrees. But to find the reference angle, well, it is greater than 90 but less than 180. So we're going to subtract it from 180 and find out it is 30 degrees. Now if we go to the previous slide, tangent of 30 degrees is square root 3 over 3. So we're saying that this is square root 3 over 3. But since we are in the second quadrant, that's negative. The whole technically the whole fraction is negative, but we can apply it to just the square root of 3 because that would turn the whole thing negative. Cosecant of 11 pi over 4. Well, first thing I'm going to do is bring this back between 0 and 2 pi by subtracting 2 pi. Part of the reason we know it's bigger than it is what? Well, 4 times 2 is what? 8. 11 is bigger than 8, so we're outside of that range. So we can subtract 2 pi and get (3 pi over 4). Now that is between 0 and 2 pi. Now, this is bigger than pi over 2, so to get our reference angle, we're going to take pi and subtract 3 pi over 4 from it, which will give us pi over 4. So our reference angle for cosecant is pi over 4. Now, cosecant is 1 over sine. So let's see what sine is at pi over 4. Sine at pi over 4 is square root 2 over 2. So cosecant would be 2 over the square root of 2. So sine, yes. Sine of 45 is square root 2 over 2. Yeah. Since we're doing cosecant, it would be flipped. Then we need to rationalize this. 2 over second square root of 2 is square root of 2. Yeah. But with any of these here, even cosecant, in the calculator, we could do 1 over sine of 11 pi over 4. We get the same thing. So the calculators can do these. Being able to do these, especially with reference angles and being able to reference back to them, was especially helpful when we didn't have a calculator that was able to do this. Now this one here is positive because 11 pi over 4, our coterminal angle was 3 pi over 4. We're still in the second quadrant, which is a positive sign. So, questions on this here? Use a calculator to evaluate each trig function. Cotangent of 410 degrees. Well, I'm going to grab the graphing calculator. Alpha y equals enter. 1 over tangent of 410 degrees. 0.8391. Part of the reason I used the calculator is it was in degrees, not radians. Where the second one, sine of -7, is in radians. Negative 0.65698, so negative 0.6570. And lastly, secant of pi over 9, we're still in radians. Secant's 1 over cosine. So we can say 1 over cosine of, I think it was pi over 9, yes? 1.0642. And that's it. Now, part of the reason I was switching between the two is, for one, I knew that the 30xs was already in radians, not in degrees. So I'll just keep plugging the ones there. I knew the graphing calculator was still in degrees, so I could plug them in there. Because I knew one of them I didn't have to switch. But if you want to continue to use the 30xs, just make sure to change back to the correct form if you're switching between degrees and radians. But that is it.